Yes, I saw it.
Okay. So is there any doubt from the previous class, or we can move to the Nernst equation?
No, that's sir.
Okay. Moving to the next topic, that is Nernst equation, and it is one of the most important topic from this chapter. So see, Nernst equation is very easy. There will be a formula which is very easy. Basically, here to calculate the value of E cell will be equal to E naught cell minus 2.303 RT upon NF log product upon reactant to the base 10. So basically, if you remember from class 11, you have calculated the value of Kc from chemical equilibrium. Do you remember it?
No, sir.
Okay, I'll just remind you. So all I want to say is that for E cell, and what is this product upon reactant? If you have an equation AA gives you BB and react with BB to give you CC gaseous state plus DD. This small a, B, C, D are coefficient, stoichiometric coefficient of A, B, C, and D respectively. And if you are going to calculate the value of Kc, which is equilibrium constant, this will be equal to product upon reactant. Product upon reactant. So first we are going for product. There are two products. The first one is C and the second one is D. So you are going to write it in multiplication term, and whatever is the its stoichiometric coefficient, that will come into the power. Upon reactant, we have two reactant raised to the power. So this is what we are talking about, product upon reactant. Are you getting my point?
Yes, sir.
One more important point is that in expression of Kc, only we consider gaseous state or aqueous state. We do not consider pure liquid or solid. Actually, we neglect that. We ignore that. Are you getting my point?
Yes, sir.
If you have let's say I'm going to take it like this. Just wait a minute. Oh my, let me. Okay. Okay. You can see, if you remember this form, equation plus U plus 2, that will give you U plus Zn plus 2. And you know, if it is in ions, that means it is in aqueous solution. It is in metallic form, that means it is in solid state. This is in aqueous state, and this is in solid state. Are you getting my point?
Yes, sir.
If you want to write the value of E cell or expression for E cell, that will be equal to E naught cell minus 2.303 RT upon NF log. Now, since we have the reaction directly, so for product, you have two products. One of the product is in solid state. You are going to neglect this, ignore this. Only one product is there, that is Zn plus 2. So you are going to write this square bracket, basically represent the concentration term, molarity. So whatever is the molarity of Zn plus 2, you are going to write it. And since only one, can you tell me the stoichiometric coefficient of Zn plus 2 here?
1.
So it will be like this. And for reactant, again, you can see one is in solid state and another is in aqueous state. So you are going to ignore solid state. So this is what product upon reactant means. And then after some time you will see this E cell will have a relation with the Kc, because you know that this product upon reactant can be replaced with Kc equilibrium constant. Please do write up to this. There will be test tomorrow up to this. Is that clear from this chapter?
Yes, sir. But I think I have a physics class tomorrow, tuition.
Uh, Physics, they will arrange the test for tomorrow. There will be, always remember this, after every 15 days, there will be a test of whatever you have studied in this 15 days. And most probably it will be on Friday or something.
Okay, yes, sir.
Okay. So they will coordinate with you.
So what happened to the log over here in that E cell thing?
Log
Yes, sir. The final equation. So E cell minus for Zn plus 2.
E cell equals to, are you talking about this or
No,
this?
no, no, the down one, the down. Yeah.
E cell is equal to E naught
Yeah.
cell minus 2.303 RT upon NF log. What I wanted to tell you is that this is the general formula. Now, sometimes you will think that this is also product, so you should consider this copper in solid state, but we don't need to consider this because we in expression of equilibrium constant, we neglect pure liquid and pure solid. We consider only gas, which will be in pressure, in terms of pressure, and aqueous, which will be in terms of concentration or molarity. Are you getting my point?
Yes, sir.
I'm gonna write whatever this represent. R is gaseous state, and T is temperature, N is number of electron transferred, F is Faraday's constant, everything. Are you done with this?
Yes, sir.
Okay. Now see, I'm gonna write all this. There is E, then there is R, there was T, there is N, there is R, there is P, like this. Anything else? Yeah. So this is your EMF of cell at any concentration and temperature. That is your EMF, E. But if you have E naught, that means a standard electrode potential or a standard EMF of cell. Are you getting my point?
Yes, sir.
Now, R, you know from class 11, the states of R is gas constant. And generally, we take here the value is 8.341 joule per Kelvin per mole. Joule per mole per Kelvin, sorry. T is temperature in Kelvin, that is understood. N is number of electron transferred. R is concentration of reactant. P is concentration of product. So basically, I had written the formula E cell is equal to E naught cell minus 2.303 RT upon NF log product upon reactant. Log product upon reactant. Now, if you want to write the value of this R, T, and F, because we know all the F is basically Faraday's constant, you know that. So we can get the value E cell, or E is equal to E naught, you can write, or if you want to write cell, you can write this as well. And if you are going to write the value of this R 8.314 and T is 25 degrees centigrade, 298 Kelvin, and F is 96,500 Coulomb, then you will be getting 0.059 upon N log product upon reactant. We didn't define this N because we don't have an equation. We don't have the reaction. If we will have the reaction, we can know about the number of electron transferred. But this, we can easily do. So this formula are used to calculate the EMF of cell. Let me know when you are done with this.
Done, sir.
So I'm gonna give you a question on this. Please do it. And let me know if you are not able to solve. Find the reduction potential. That means electrode potential E cell. And you also need to calculate the oxidation potential. Of Fe plus 2. The representation is given as this. And it is also given that E naught Fe plus 2 slash Fe. The standard electrode potential is given as this. I think you can do this. Now, will you be able to solve this?
No, sir, can you do it?
Okay. So first question, it is based upon um, Nernst equation, so no need to worry. First of all, you need to calculate E cell, right? Yes or no?
Yes.
How you are going to recognize it? As I already told you in the previous lecture, that this reduction potential is equal to electrode potential, right?
Yes.
And electrode potential of cell we are talking about. So we need to calculate E cell. And if you are able to calculate electrode potential, that will be equal to reduction potential. And if you are going to do opposite sign of reduction potential, you will get oxidation potential, right? So our first priority is to calculate E cell. And E naught cell is given. So for E cell, you have got the formula E naught cell minus 0.059 upon N log of product upon reactant. It's very simple. Now, as you can see here that it is at 25 degrees centigrade. So most probably it is, you can see it is at a standard condition. That's why we directly used this formula 0.059. Are you getting my point? There was 2.303 RT upon NF. And if you are going to write the value of R and T at 298 Kelvin and R 8.314 and Faraday's 96,500 Coulomb, then you will be able to get this. Are you getting my point, Austin?
Yes, sir. Yes.
Now, you cannot see reactant and product in the reaction, but there is a hint, that is the representation. And from representation, you can easily write a reaction. Fe plus 2, you can see it's going into Fe. That means it gained 2 electrons to convert itself into Fe. Yes or no?
Yes, sir.
Now, this is your reactant and this is your product. Now, I'm going to put the value E cell as it is. We need to calculate E naught cell has a value that is given as minus 0.45 minus 0.059 upon number of electron. You can see how many number of electron gained or lost. Here it is gaining. So 2 log of product. Product is in solid state. So you have to leave it. You have to ignore it, as I told you. Austin.
Yes, sir.
And reactant, you can see reactant is Fe plus 2. You need to write the concentration of Fe plus 2 because it is in aqueous state, and in the question concentration is given as 10 raised to the power minus 2. And then I think you can solve it, right? Please do solve it.
Yes.
You know, this question is based upon half cell reaction, reduction half cell reaction. There will be question on oxidation half cell reaction, and there will be complete cell reaction like redox reaction. Are you getting my point?
Yes, sir.
So I think you can do this. Please do this. Let me know the answer, then we can move to the next. Should I solve it, or are you able to solve it?
I'm able to solve.
No. So it will be E cell is equal to 0.45 minus, you can see I'm gonna round it off and it will be 0.06, right? And in denominator it is 2 log upon 2 log of, when it will move upward it will be 10 raised to the power 2. Now you can see it will be 0.45 and you can see 0.06 upon 2. The formula of power of the log, this will come here, 2 into log 10. I think you know that the value of log 10 is 1, and this 2 will be cancelled, and then minus 0.45 minus 0.06, together it will make it 0.51 minus 0.5. This is the value of E cell. That means reduction potential will also have 0.51 volt negative. And if you want to calculate the oxidation potential, just change the sign and you will get plus 0.51 volt. Got it?
Yes.
So can I change the slide?
Yes.
Okay, so I think you are aware of this basic maths of log. Yes or no?
Yes.
Like when I moved this 2 here, are you able to understand this?
Yes,
Whatever
sir.
is the power,
Yes.
very good. Okay, very good. That's good. Now I'm gonna give you another question. This is also basically, just wait. Find again same question: reduction potential and oxidation potential of. It is given that chromium solid goes into chromium plus 3, 0.01 m at 25 degrees centigrade. Also, E naught Cr plus 3 slash Cr is given as minus 0.75. You need to calculate Rb and Ep, OP. Oh, very good. Very good. It's the right answer. That is uh, oxidation potential, positive reduction potential. Very good. So basically, this was quite easy. Now I'm gonna give you a question which is redox reaction. Matlab, that means complete cell reaction, and which is also easy. You just need to follow your concept and you will be able to calculate it. Find EMF of cell, and here you can see you have written the reaction according to this representation, right, Austin?
Yes, sir.
So you are going to write the representation, write the reaction according to this representation, the one which I'm gonna write here. 0.1 m is given double slash Fe plus 2 equals slash Fe solid, and here the concentration is 0.001 m. Also, it is given that E naught Cr plus 3 slash Cr is equal to minus 0.75 volt, and E naught Fe plus 2 slash Fe, that will be equal to minus 0.45. So I think you can do this if you think about it. Please do it. Any answer?
Doing so.
Yes or no?
I'm doing so.
No.
I'm doing it, sir. I'm doing it.
Okay. See, I didn't get you clearly. Are you able to solve this? Yes or no?
Yes, sir. I will solve it.
You are solving it. Okay, take your time. I'm waiting for the answer.
So is it 2? I'm not sure.
Are you saying 2 volt?
Yes, sir.
Okay. No, I don't think 2 it is. See, first of all, we need to calculate EMF of cell and representation is given. So with the help of representation, uh, I'm going to write the reaction. I'm going to write the reaction. So this will be the balanced reaction, yes or no?
Oh, yes, sir. I forgot to do this.
Okay, tell me how many number of electrons you have taken. N equals to,
I
just
took 2.
just wait, I'll ask it again. If I'm going to write the formula, E cell will be equal to E naught cell minus 0.059 upon N log of product. Let me show you. The product is very important to write. This is in solid state, so you are going to leave it. Yes or no?
Yes, sir.
So this is in aqueous state. So concentration of Cr plus 3 and whatever is the stoichiometric coefficient that will come into power. Yes or no?
Yes, sir.
Have you done it same?
No, sir. I forgot to do the stoichiometry.
Okay. Now again see, this is in your solid state. So you are going to ignore it. So you have concentration of Fe plus 2 raised to the power 3. Now the most important point. You understood these 2 points?
Yes, sir. Yes.
Now tell me the value of number of electrons.
I took 2, sir.
How many electrons have you taken? The value of N.
2. 2.
It will not be 2. See, it will be 2 for one element, but we calculate for the balanced equation. So you can see it is going from Fe plus 2 to Fe. That means one iron atom lost, sorry, gained 2 electron, one iron atoms. But there are how many iron atoms?
Oh, yes, sir. 3.
3. So the number of
6.
electrons will be
6.
So now you are going to put the value and then calculate it. Yeah, first of all, have you calculated the value of E naught cell?
Yes, sir. I got
What is the value?
0.30.
Very good. E naught cell is equal to, E naught right minus E naught left. And that comes from here. Right is on iron. And you can see iron is minus 0.45. And again, when it will be more plus 0.75. So that that's a correct answer, 0.30. And accordingly, you can write the value in not cell 0.30. Sorry, 0.030 I have written 0.30 minus, you can do this 0.06 upon 6 log of CR plus 3. You can see the it is 10 raised to the power 1 raised to the power 2 and 10 raised to the power 3 raised to the power 2. 3. No. Yeah, it is 3. So I think you can do this now. Yes or no?
Yes.
Please do complete this. Then we will move to the equilibrium constant from Nernst equation.
So actually, I'm not sure how you do the experiments over here. Can you do it?
Uh, what did you say?
I'm not sure how to calculate the exponential.
Okay, see, it's very easy. So what you are going to do, it's very easy. Just wait a minute. This will be cancelled by 0.01. Yes or no?
Yes, sir.
Now you can see 0.30 minus 0.01 log of, you can see this will be your 10 raised to the power minus 2. And this will be your 10 raised to the power what? 9?
-9.
Minus 9. Just wait a minute. Have I taken the wrong value or right value? Yeah, minus 9. When it will go up, it will be in positive, right? So I
Yes,
think we will have left 10 raised to the power 7. Yes or no?
yes, sir.
Now you can see the power will move to this side, and then you know that 0.30 minus 0.01 into 7 and log 10. Log 10 has a value of what? 1.
Yes, sir. Yes.
And now you can see 0.30 minus 0.07. So it will be equal to what? 0.23.
Yes, sir.
So this is your reset.
Yes, sir.
Oh, just wait a minute, done.
Done, sir.
Okay. That's great. Okay. Now see, the next topic is equilibrium constant from Nernst equation. The right topic. Equilibrium constant from Nernst equation. Now, as you know that, are you aware that when the what will be the value of delta G when the system or process is in equilibrium? what will be the value of delta G?
0.
Yes. That means at equilibrium, delta G will be equal to 0. And you know that delta G will be equal to minus NF E cell. So the number of the number of electron gained or lost will not be equal to 0. The Faraday's constant is also not equals to 0. That means E cell will be equal to 0 if delta G equals to 0. Yes or no?
Yes, sir.
So E cell will be equal to 0. So if you are going to write the Nernst equation, E cell is equal to E naught cell minus 2.303 RT upon NF log of product upon reactant. Since E cell equals to 0, that means we can easily write E naught cell will be equal to E naught cell will be equal to 2.303 RT upon NF, and this will be equal to, since the process or the system is in equilibrium, so product upon reactant will be equal to Kc. That is equilibrium constant. Please do that. Let me know when you are done with this. Are you done with this?
Yes, sir.
This is your E naught, not exclamation sign. Please do it. Are you able to see the screen?
Yes, sir.
Please do it.
So option C.
What is the answer?
C.
Austin, you know,
Option C.
option C. Very good. Just wait a minute. I'm gonna give you. Now do this. Will you be able to solve this?
Yes, sir, but this is not an equilibrium question, right?
It's not.
Equilibrium, right?
No,
Equilibrium.
no.
Okay.
No, it's not equilibrium. It is basically based upon the Gibbs free energy. We need to calculate the delta G naught now, and I had given a formula for delta G naught that is equal to what?
Yes.
So the value of this is also given. You know the value of this, and from the equation you can easily calculate the value of n.
Yes.
Let me know if you have got the answer. Any answer for the
Uh,
question number 30?
I'm doing so. Yeah, N is 2, right?
Yeah, n is 2.
Okay, yes.
So you are going to write 2 into here, it will be 96,500 and 0.24. So it will be 46 negative 46320 joule per mole. But you need answer in kilojoule per mole. So it will be 46.32 kilojoule per mole, right?
Yes, sir.
And it is of negative. So the answer is A. Go for question number 32.
So I'm not sure to do this one.
What did you say?
So I don't know how to do this one.
Okay, no problem. See, the pressure of H2, we need to calculate the pressure of H2 required to make potential of H2 electrode, hydrogen electrode, 0. Actually, the electrode potential of hydrogen is always 0 because the electrode potential of all the elements calculated with reference to this hydrogen. So we took hydrogen's electrode potential as 0 in pure water at 298 Kelvin. Now see, it's very easy to calculate. If you want to make H2, first of all, 2H plus will convert itself into H2 and it will gain 2 electron to convert it into H2. Yes or no?
Yes, sir.
Just wait a minute. There is a call from coaching. Nihal, am I audible?
Yeah, I'm here.
Nihal, your class for applied mathematics will be at 8:30 p.m. IST. 8:30 IST.
What is that for EST?
IST, like according to Indian time, the time will be at 8:30 after 1 hour, just after 1 hour for
After one
applied
hour
math.
from now?
Yes, from now, exactly from now.
So Jaha sir will be here or it's you from now?
Jad sir will be there.
Okay, all right, thank you.
Okay. Yes, Austin there.
Yes, sir.
So to get H2, you have to convert H plus. H plus will gain electron to convert itself into H2. Now you are going to apply the Nernst equation to this formula. So E will be equal to E naught minus 0.059 upon N. N is how much? 2. Log of, as I told you, gaseous state or aqueous state only be considerable in equilibrium constant expression. So you are going to write pH2 upon H plus raised to the power 2. As I told you, whatever is in gaseous state, then we express this in pressure terms. And whenever it is in aqueous state, we are going to express this in concentration, that means molarity terms. Are you getting my point?
Yes, sir.
Now you just need to simple do mathematics. As I also told you that the for hydrogen it is 0, so you are going to write a 0 0 minus, and here it will be 0.059 upon 2 log of pH2, pressure of dihydrogen. So you just need to take 1. Why? Atmospheric pressure you can take, and here you can see H plus. Just wait a minute. The pressure of H2 required to make the potential. Okay, not a problem. Now see, since it is pure water, do you know what does pure water means? Pure water means pH of that solution will be 14. Neutral it will be. Yes or no?
14 is neutral. 7, right?
Sorry. pH will be pH equals to 7. That will be neutral. Yes or no?
Yes, sir.
Now, since H plus is there, what will be the concentration of H plus? What will be the concentration of H plus? It will be 10 raised to the power minus 7. See, in water, this question is quite good. In water, you have two parts, H plus and OH minus. Yes or no?
Yes, sir.
So this will have to 10 raised to the power almost minus 7 because it is in pure water and it is almost what? It is almost neutral. So pH will
Yes,
be
sir.
7
Yeah,
for 10
yeah,
raised to the power minus 7. Yes or no?
yeah. Yes, sir. Yeah.
And you can easily replace this 10 raised to the power minus 7 raised to the power 2 because of this stoichiometric coefficient, and accordingly you can calculate the pressure. We needed to calculate pH 2, so you need to calculate this. Atmospheric pressure is not given, so you can easily calculate this. Are you getting my point, or should I
Yes, sir.
again explain it?
I'm getting, sir.
Okay, please do it. Then I will move to the next question or next topic. Now I'm going to give you another question on this. Are you done?
Yes, sir. Option A.
Very good. And for this, just let me check for option D. Yeah. Can you option D or option A?
Option A.
Yeah, option A it is. 10 raised to the power minus 14, right?
Yes, sir.
Okay, go for 48.
So I'm getting into the last part, but I don't know how to divide by log.
Yes. Just
So,
wait a minute.
yes.
My pen tab is a little bit. Now, can you repeat your? Were you able to solve this? Yes or no?
No, sir. I'm getting into the last part, but I don't know how to divide by log.
Okay, see, it's very easy. Standard EMF of a galvanic cell involving cell reaction with N is equal to 2. Okay, is found to be 0.9295 volt at 25 degrees centigrade. The equilibrium constant for the reaction would be, you know that, if you remember, I had given a formula for this. What was the formula?
A is equal to um,
We can directly write log 10, k to the base 10 will be equal to what? N into E upon 0.059. Yes or no?
yes, sir.
Or it was the same, like E is equal to 0.059 upon N log K. This was the formula. So actually I wrote the formula
Yes,
which we needed, right? So
yes,
N is 2, this E is 0.295, this 0.59. Now you can easily calculate the value of log 10, log K to the base 10, and calculating the value of K. You just wait a minute. Let me multiply it and show it to you. Can you tell me after multiplication what you will get? 2 5 ja 10, 2 9 ja 18, and 2 2 ja 4 5. This will be the scenario. Yes or no?
yes, sir.
Now you can see that only 10 will be left there. That means basically if you are going to solve it, you will get 10. That means log k to the base 10 will be equal to 10. So taking anti-log, then k will be equal to whatever here will become in power, 10 raised to the power 10. So the answer according to this will be D.
Yes.
That is good. So this is it about this. Now, can we move to the next topic?
So what's it?
No, please do that. Very good. Now see, the next topic is electrochemical series. So see, this is a series on which if you know the value, basically it is based upon the increasing or decreasing order of electrode potential value. If you know the value of different elements or the ions of the of their electrode potential, then you can easily arrange them in increasing or decreasing order of oxidizing or reducing behavior. Are you getting my point?
Yes, sir.
So electrochemical series, I'm going to write from here. Lithium, this is a series. Maybe I'm going to write after this here, but this series will be just below this first one. Are you getting my point?
Yes, sir.
So I'm going to write here lithium, then potassium, barium, strontium, calcium, sodium, magnesium, aluminum, manganese, zinc, chromium. Then comes your iron. This is below this: cadmium, cobalt, nickel, tin, lead. After that comes hydrogen. And here the value of hydrogen's electrode potential is equal to 0. As I told you that the value of electrode potential for different elements calculated with reference to this hydrogen, and that's why the hydrogen's electrode potential we take 0. Then comes your copper, iodine, silver, mercury, bromine, platinum, oxygen, chlorine, gold, and then fluorine. The most important point here is that these all are negative. These all are negative. E naught R, E naught R negative. The most important point is that this is the most negative. Most negative. What I want to say is that the value of E naught R of lithium is the highest one in negative and then decreasing order in negative. Are you getting my point? Let's say
Yes, sir.
lithium has -5 volt, then potassium will have 4.8, then decreasing and decreasing till hydrogen is 0. And these all have E naught R value, which is positive. So this is the series. Are you getting my point?
Yes, sir.
So please do write it. Lithium most negative, fluorine most positive. And you know what? Fluorine is the most oxidizing agent. That means basically the E naught R value of anything which is high or greater, then it will be most oxidizing. It will have most oxidizing power. Are you getting my point?
Yes, sir.
So in this way, you can easily decide which one will have more oxidizing power, less oxidizing power. Lithium most reducing agent. That means it has negative value highest. So you can say like this: negative value, that is lesser. We generally take it lesser. So E naught R value decreases, reducing power increases. Or E naught R value increases, oxidizing power increases. Got it? Please do write it. Are you done with this?
No, sir.
Yes or no?
Sir.
Okay. So there are some points I need to write here. Write the topic first. Characteristics of electrochemical series ECS. The first one, which is very important, E naught R value of hydrogen 0. The second one, elements like above hydrogen have E naught R equals to negative. Third, we can write elements lie below hydrogen have E naught R is equal to positive. I think you are getting this because I
Yes.
told you the first row is the second row is just below the first row, the third row is just below the second row, and the fourth row is just below the third row. Top to bottom, you know, from negative to positive, that means E naught R value increases. 5. This you already know. Most negative, lowest E naught R value. You can write this. Chlorine, most positive, highest E naught R. Please do write it, then let me know.